From the smallest particles to the largest structures, the universe is shaped by quantum whispers. In the earliest instant after the Big Bang, the universe was governed not by stars and galaxies, but by quantum fluctuations, brief, random variations in energy. These tiny differences were amplified during cosmic inflation, stretching quantum imprints across unimaginable scales. Over billions of years, those fluctuations grew into the cosmic web, the vast, filamentary structure that defines the universe today. When we observe the Triangulum Galaxy, we're not just seeing a spiral of stars. We're seeing a node in a much larger tapestry, one stitched together by dark matter and shaped by quantum chance. The galaxies we observe, including Triangulum, tend to form along these filaments of invisible matter, interconnected like the threads of a cosmic spiderweb. Between these filaments lie cosmic voids, vast, empty regions stretching millions of light-years across. And yet all of this, every galaxy cluster, every glowing star, originated from tiny ripples in the early universe. These ripples, born of quantum uncertainty, determined where matter would gather and where it would not. It's a staggering thought that the shape of the universe on the largest scales is dictated by laws that govern the tiniest particles. The clustering of galaxies, the distribution of dark matter, even the voids between stars, all are statistical expressions of those first quantum fluctuations. In this sense, the cosmos is not a chaotic explosion, but a precise unfolding of probabilities. Triangulum's place in the universe was determined not by chance, but by quantum law. The same laws that dictate electron orbits and photon behavior also govern where galaxies form, how they move, and how they connect. The cosmic web is not visible to the eye, but its effects are unmistakable. Galaxies do not distribute randomly. They form clusters, walls, and filaments. The Triangulum Galaxy belongs to the local group, which itself is embedded in a filament of the Laniakea supercluster. That filament curves through space, connecting Milky Way, Andromeda, and hundreds of other galaxies in a delicate gravitational balance. And the invisible glue holding it together? Dark matter. Though we cannot see it, dark matter is the scaffold of the cosmos, providing the framework on which ordinary matter gathers. It responds to gravity, but not light. It's 5 times more abundant than visible matter, and its distribution was set, in part, by those primordial quantum fluctuations. Simulations of the early universe, such as the Millennium simulation, have shown how these fluctuations evolved into the cosmic web. The resulting maps are eerily similar to what we observe with telescopes. That alignment tells us that quantum physics didn't just shape the microworld, it shaped everything. Triangulum is one point on a billion light-year-long thread of gravity and dark matter. Every star in it, every planet, is part of a larger structure that is itself part of something grander still. This web is not static. It evolves as gravity pulls galaxies closer, as clusters merge, and as dark energy pushes space apart. Over time, the cosmic web becomes more intricate and more stretched. In the distant future, entire filaments may become isolated as dark energy accelerates expansion. Yet the imprint of quantum origin will remain. Every galaxy will still trace the same ancient scaffolding. And perhaps most profoundly, we are a part of that. The atoms in our bodies, forged in stars, arranged into molecules and minds, ultimately follow the same statistical distributions seeded by quantum mechanics. That means we, like Triangulum, are products of uncertainty, not randomness, but structured possibility. From quantum ripples to galaxies to consciousness, a hierarchy of emergence written into the universe from its very first moment. To contemplate the cosmic web is to contemplate our place in the grand scheme. We are not separate from the universe, we are threads within it. The Triangulum Galaxy is not floating in isolation. It is embedded, anchored, and connected to all things by the invisible strands of cosmic geometry. In this web, everything is related. Every fluctuation, every filament, every star. Each plays its part in the orchestra of the cosmos. And in that music, you can still hear the quantum beat of creation.